a Y system, the three phases are shifted by 120 degrees from each other. This signifies that the voltage of each phase reaches its peak at different times. For single-phase loads, the voltage is taken between one phase and the neutral. The current flowing through each phase will be current equals voltage divided by impedance. The voltage for a single-phase load in a Y system is voltage equals phase voltage equals 208 volts. The impedance for a load is typically not provided in the question. However, the electrical inspector assumes that the impedance of the load is purely resistive and is equal to the load resistance. Therefore, the impedance can be calculated as impedance equals resistance equals voltage divided by current. The electrical inspector appears to be using a simplified method to calculate the current for single-phase loads in a Y system. This method is based on the assumption that the impedance of the load is purely resistive and equal to the load resistance. The derivation of the 1.15 multiplier is as follows: voltage equals 208 volts. Current equals 24 amps from the example. Resistance equals voltage divided by current equals 208 volts divided by 24 amps, which is approximately 8.67 ohms. The 1.15 multiplier is then obtained by taking the square root of 3. That is to say, 1.15 equals the square root of 3. The simplified method assumes that the impedance of the load is purely resistive. In reality, loads may have both resistive and inductive components. However, for many common loads, the inductive component is negligible. The 1.15 multiplier compensates for the phase shift in the Y system. It ensures that the current calculated using this simplified method is approximately equal to the actual current flowing through the load. The simplified method described by the electrical inspector is an approximation based on certain assumptions. It can be used to calculate the amperage for single-phase loads in a Y system when the load impedance is assumed to be purely resistive. However, it is important to note that this method may not be accurate for loads with significant inductive components.